Solve the following equations for x. The first equation, log 10, that is log s to base 10 rather, is equal to 3. This implies s is equal to 10 to the power of 3, s equal to 1000. I have this in logarithmic form. I express it in index form. 10 to the power of 3 is equal to x. That is graph for A. Then the B6, log 27 to base s equal to 3. Expressing this in index form. That means s to the power of 3, this to the power of this, equal to 27. S to the power of 3 equal to 3 to the power of 3. That is 27 is 3 to the power of 3. Since the power are the same, 3, 3, you can equate the basis s is equal to 3. On question C, we have log 1 over 16 to base s equal to negative 1 over 2. Expressing this in index form, s to the power of negative 1 over 2 is equal to 1 over 16. This implies, now to remove these negative indices or negative index, that will be 1 over x to the power of half equal to 1 over 16, which means x to the power of half is equal to 16. I cross multiply 1 times this is still 1 x to the power of half, and 1 times 16 is still 16. To remove this half here, I'll multiply both power by 2. So this multiplied by 2 and 16 to the power of 1 multiplied by 2. So this can go, x is equal to 16 to the power of 2, that's 16 times 16, which is 256. So s is 256. Move on to d. D is 3 to the power of s equal to 1. To make the basis equal here, we know that any number raised to the power of 0 is 1. So I'm going to raise this become 3 to the power of 0. These and these are equivalent. Now the bases are the same, which implies s is equal to 0. In question E, we have 4 to the power of x plus 1 equal to 8 to the power of x. Expressing each of these in index form, if I express this in index form, I have 2 to the power of 244, then multiply by this s plus 1 equal to 2 to the power of 348, multiply by this s, which is 2 to the power, 2 times x is 2x, and 2 times 1 is 2, equal to 2 to the power of 3x. This implies the bases are the same, so we can equate the powers. 2s plus 2 is equal to 3s. Collecting items, 2x minus 3s equal to minus 2. As I move this across, the equality become minus. Also move this across, the equality become minus. Okay, 2s minus 3s is minus x equal to minus 2. Minus will cancel out. Therefore, s is equal to 2. Okay, we have question F now. And F says 2 to the power of x multiplied by 2 to the power of 3x minus 1 is equal to 1. Now, applying the first law of indices a to the power of s times a to the power of y, for example, is a to the power of s plus y. If I apply it here, I'll have 2 to the power of s plus 3s minus 1 equal to 1, which is 2 to the power of x plus 3s is 4s, then minus 1 equal to, any number to the power of 0 is 1, so this one I will turn into 2 to the power of 0, so that the bases will be equal. Now the bases are the same, we can equate the powers. 4s minus 1 is equal to 0. That means 4s is equal to 1. Divide both sides by 4. S is equal to 1 over 4. So in this 4 we cancel this. And this question F. Now let's do question G here. So this place will be enough. G says 2 to the power of 2x minus 3 times 2 to the power of x plus 2 equal to 0. And this one is going to lead us to quadratic equation. And before we do anything, let me adjust this first term here so that I have 2 to the power of s, because I have 2 to the power of s here. So this 2 to the power of 2s, I can write it as 2 to the power of s to the power of 2 and minus 3 times 2 to the power of s plus 2 equal to 0. I have 2 to the power of s here, I have it here, so I can substitute it with anything. Let me use p. Let p be equal to 2 to the power of s, so that this place now becomes p squared. Now the musician minus 3 times p, since I have another 2 to the power of s there, and plus 2 equal to 0. Okay? Now this is quadratic, so let's solve that. P squared times 2 is 2p squared. Then we look for 2 factors of 2p squared that can add up to this. Factors of 2 are just 2 and 1. So 2p and 1p. How do you add 2p and 1p to get minus 3p? Both of them have to be minus. Now that I know the factors, I'll replace this middle term with the factors, so that I have p squared minus 2p minus p plus 2 equal to 0. Now if I group this 2 by 2, that is the p squared minus 2p minus p minus 2. This plus change to minus because I introduce a bracket. Now p is common there. So p minus 2. Here 1 is common. P minus 2 equal to 0. And p minus 2 and p minus 1 equal to 0. You see that p minus 2 is equal to 0, or p minus 1 is equal to 0. P therefore is 2 or 1. But it's x we are looking for. So now that we know p, we said earlier that p is 2 to the power of x. So that p is 2 to the power of x. So when p is, what were the value of p? 2 and 1. When p is equal to 2, that means 2 to the power of x is equal to 2. The power of 2 here is 1. Even when it is not written, we know that the power is 1. The bases are the same, so x is equal to, we equate the power, x is equal to 1. Again, when p is equal to 1, 2 to the power of x is equal to 1, which implies 2 to the power of x. I'm turning this 1 to 2 to the power of 0, since I know that any number to the power of 0 is 1. I'm doing that so that the bases will be the same. So now we have the bases to be equal. We can equate the powers. S is equal to 0. Therefore, the final answer to that question is S is equal to 0 and 1. Okay, now we'll move on to question number. We just solved question G, so we'll move on to H. Question H is 3 to the power of 2x plus 6 times 3 to the power of x minus 27 equal to 0. Again, I have 3 to the power of x here, so I will adjust this first term so that I will have 3 to the power of s in both sides. I will replace it. In this first term, we can write that as 3 to the power of s, then to the power of 2 plus 6 times 3 to the power of x minus 27 equal to 0. So I have 3 to the power of s here, I have it here, I can replace it. Again, let me use p. So here the first one will be Okay, let me write this. Let p be equal to 3 to the power of s. The first term then becomes p squared 6 times p minus 27 equal to 0. This is quadratic. Multiply the first term by the last term, that's minus 27p squared. Look for two factors of minus 27p squared that can add up to this middle term plus 6p. That should be 9p and 3p. Since 9 times 3 is 27, but how do we add 9p and 3p to have this? This has to be plus and this has to be minus. So that now that we know the factors, we'll replace the middle term. Middle term rather, not terms. Middle term with the factor. So I'll have p squared plus 9p minus 3p minus 27 equal to 0. If I group these 2 by 2, I will have minus 3p plus 27 equal to 0. You notice that this minus change to plus because of the bracket I introduced. We can factor the common factor p is common here. P into p plus 9 minus 3 into p plus 9 equal to 0. P plus 9 is common equal to 0. That means p minus plus 9 rather is equal to 0, or p minus 3 equal to 0. P therefore is minus 9. When this one come here, that is 0 minus 9 is minus 9, or p equal to 3. When this come here, it becomes 0, 0 plus 3, which is 3. But p is 3 to the power of x. So let's go back there. P is 3 to the power of x. When p is equal to 3, which is one of the values we just calculated, 3 to the power of x is equal to 3 to the power of 1, meaning s is equal to 1. When p is equal to minus 9, 3 to the power of s equal to minus 9. In this case, there is no solution. There is no way a positive number will become equal to a negative number. It's not possible. So there's no solution here. The only solution that satisfies that equation is s equal to 1. Let's move on to the next one. We are in I now, question I. Question I says 2 to the power of 2x plus 1 minus 9 times 2 to the power of x plus 4 equal to 0. Here, because of this plus 1 here, I will write it as 2 to the power of 2x times 2 to the power of 1. Applying the first law of indices, if I have 2 to the power of 2s times 2 to the power of 1, and I want to turn it to a singular indices, that should be 2 to the power of 2s plus 1, which you already know. So our question is in this form. I split it up to this form. Then minus 9 times 2 to the power of s plus 4 equal to 0. Now, this 2 to the power of 2s, we can still write it as 2 to the power of s, then to the power of 2, then multiply by these 2 right here, minus 9 times 2 to the power of s plus 4 equal to 0. I want to replace 2 to the power of s now, so let it be p. Let p be 2 to the power of x, so that anywhere I see 2 to the power of x, I'm going to replace it with p. So the first one here will be p squared. Then p squared times these 2 will be 2p squared minus 9. Again, this is another 2 to the power of s. 2 to the power of s is now p. P times 9 is 9p plus 4 equal to 0. Again, we arrive at quadratic equation. 2p squared times 4 is 8p squared. Two factors of 8p squared that can add up to 9. That should be 8 and 1. So 8p and 1p, both of them have to be minus. because we're looking for minus 9. So that this equation now becomes 2p squared minus 8p minus p plus 4 equal to 0. If we group it 2 by 2, we have this, and p minus 4 equal to 0. 2p is common here. 2p into p minus 4. Then here 1 is common. P minus 4 equal to 0. We have a common factor p minus 4. Then we'll group the other one together equal to 0. Either p minus 4 is equal to 0 or 2p minus 1 equal to 0. P is 4 or 2p is 1. P is 4 or dividing both sides by 2 here, or p is half. We'll go back to the value of p, which is 2 to the power of x. So when p is equal to, what are the value of p? 4 or half. When p is equal to 4, that means 2 to the power of s is equal to 4, which implies 2 to the power of s is 2 to the power of 2, 4 expressed in index form. The bases are the same, so we put the powers, s is equal to 2. Again, when p is equal to half, that means 2 to the power of s is equal to 1 over 2. 2 to the power of s is 2 to the power of negative 1. S is equal to negative 1. So the values that satisfy this equation is s equal to 2 and s equal to negative 1. Question J is 6 log x plus 4 equal to log 64. This you can write as log x plus 4 equal to log 64. I can write that as 2 to the power of 6. 2 to the power of 6. Because 2 to the power of 6 is 2 to the 2 times 2 times 10 is 6 places, which is 64. And that will be 6 log s plus 4 equal to 6 log 2. This 6 will cancel out. So that I have log x plus 4 equal to log 2. The log will cancel. S plus 4 equal to 2. S equal to 2 minus 4. S is minus 2. Okay, I have 9 to the power of 2s plus 1 equal to 81 to the power of x minus 2 all over 3 to the power of x. Okay, I'm going to cross multiply here. So I have 9 to the power of 2x plus 1 multiplied by 3 to the power of x equal to 81 to the power of x minus 2. Now reducing this to index form, that is 3 to the power of 2, then multiply by this 2x plus 1, multiply by this 3 to the power of x, equal to, I'll reduce this to index form to 3 to the power of 4, then multiply by this s minus 2, which will give me 3. Now distributing this to 2 times this is 4s, then 2 times this is 2, multiply by 3 to the power of s equal to, distributing this 4, I'll have 4s minus 8, so that 3 to the power of 4s plus 2, then plus this s, I'm applying the first law of indices, for the 3 to the power of 4s minus 8, 4s plus s is 5s, so I have 3 to the power of 5s plus 2 is equal to 3 to the power of 4s minus 8. The bases are the same, so we put the powers plus 2 equal to 4s minus 8. Collecting like terms, 5s minus 4s equal to negative 8. This one comes here become minus 2. So that 5s minus 4s is s equal to negative 10. For L, we have log 2x plus 1 to base 10, what is it, minus log 3x minus 2 to base 10 equal to 1. Okay, log 2s plus 1 to base 10 minus log 3s minus 2 to base 10 equal to 1. Applying the law of logarithm, we have one of the laws of logarithm. We have 2x plus 1 over 3x minus 2 to base 10 equal to 1. I'm going to turn this now to index form. Logarithm of a number p to base a is the index x to which a must be raised to be equal to p. That means 2s plus 1 over 3s minus 2 is equal to 10 to the power of 1, which is 10, excuse me, plus multiply. I'll have 2x plus 1. Remember, this 10 is over 1. 2s plus 1 is 2s plus 1 equal to 10 multiplied by this 3x minus 2. So 2x plus 1 is equal to 30x minus 20. 10 times 3 is 30 and 10 times negative 2 is negative 20. Collecting like times 2x minus 30 is equal to minus 20 minus 1. 2x minus 30 is minus 28. X equal to minus 21. Divide both sides by minus 28. Minus 28. Here we go. S equal to 7 here 3, 7 here 4. So S is 3 over 4. Now question M, we have 3 multiplied by 9 to the power of 1 plus x equal to 27 to the power of negative s. This will give us, expressing this in index form, that is 3 squared, then multiply by 1 plus x equal to, expressing 27 in index form is 3 to the power of 3, multiplied by negative s is negative s. So that will be negative 3s rather. Okay, now the power of this 3 here is 1. Before that, let me distribute these two here. So I'll have 3 to the power of 1 multiplied by 3 to the power of 2 plus 2s equal to 3 to the power of negative 3s. So that when we apply the first law of indices here, we have 3 to the power of 1 plus 2 plus 2x equal to 3 to the power of negative 3x. Which gives us 1 plus 2 is 3, 3 to the power of 3 plus 2s equal to 3 to the power of negative 3s, which gives us 3 to the power. Okay, the bases are the same, so let's equate the powers. 3 plus 2s equal to negative 3s. Collecting items 3 is equal to negative 3s on minus 2 minus 2x. 3 equal to negative 5x. Divide both sides by negative 5. So this can go. S therefore is negative 3 over 5. And finally, the last question, which is N, says log 3x minus 1 to base 10 minus log 2 to base 10 equal to 3. If I apply the first law, one of the laws of logarithm, I'll have to divide this. So I'll have log 3x minus 1 over 2 to base 10 equal to 3, which when I convert this to index form, I will have 3x minus 1 over 2 equal to 10 to the power of 3, and that will give me 3s minus 1 over 2 equal to 10 to the power of 3 is 8,000. Cross multiply 3s is equal to 1,000 times 2. 3s minus 1 rather, minus 1 is equal to 2,000. S equal to 3s equal to 2,001. That is, this one come here and add s will be 2,001 divided by 3, which is 667.